Example 2.3. Figure A and B show the field lines of positive and negative point charges respectively. So first figure connected to positive charge. We can make out here arrows are outward. This is negative charge. Therefore arrows are inward. We'll go to first question now. Give the signs of potential difference Vp minus Vq and Vb minus Va. We have to give the sign. Okay, first part, potential. What is the formula for potential? Due to point charge, V equal to KQ by R. Now, we have to find the sign for Vp minus Vq. According to the formula, potential proportional to 1 by R, Q is constant here, K is also constant. In other words, as separation increases, potential decreases. Now, OP and OQ, which is more? Separation, OQ is more. As separation increases, potential decreases. Therefore, potential at Q is less compared to potential at A. Vp is greater than Vq. This implies Vp minus Vq is greater than 0. That is, Vp minus Vq is positive. Okay. Now we'll go for the second point, second figure. Now you should be very careful because at the center, negative charge is kept. Negative charge is kept. Potential at A, in the first case, what you have written, near point mein potential is more. Yes, potential at A is more than potential at B if it is a positive charge. Now, if it is a negative charge, negative sign, right? Negative sign. So, negative value minus, for example, minus 3 and minus 4. Which is larger? Which is larger? Minus 3 is larger than minus 4. Therefore, this is a negative potential. Therefore, what happens? VA potential is less and VB potential is more. Therefore, VB minus VA is greater than 0. VB minus VA is greater than 0. Now, I will explain this with an example. Let OA distance is 3 cm. Just we will imagine any value. Similarly, OB equal to 4 cm. In the diagram, we can make out OA is shorter distance, OB is larger distance. Potential formula, that is V equal to KQ by R. Now Q value is minus here. So potential proportional to minus Q by 3. Let us take Q equal to 1 unit. So potential proportional to minus 1 by 3, that is minus 0.33. Similarly, go for potential at B. Potential at B becomes minus 0.25. Minus 0.33. It is 0.33 is a smaller value, but minus 0.33 is a larger value. That is potential 0.33 and 0.25. Compare these two with, suppose negative sign is not there, then 0.25 is smaller. 0.33. Now, minus 0.25 value is larger than minus 0.33. That is, potential at B is greater than potential at A. Now, we'll go for the part B. Give the sign of potential energy difference of a small negative charge between the point Q and P as well as A and B. Okay, first we'll go for this. Now, sign of potential energy. What is the formula for potential energy? Potential energy equal to charge into potential, right? Now, the sign of potential energy difference for a small negative charge. We have to be very careful. Negative charge. Okay. For negative charge means Q value is less than 0. And Vp, this we have already discussed now. A negative charge, Vp is greater than Vq. Potential at P is greater than potential at Q. Now, potential energy formula, charge into potential, right? Potential energy at P equal to charge into potential at B. Vp is more, that is more negative. Similarly, Q is Q into Vq, it is less negative. Potential energy at P is less than potential energy at Q. That is, Vp UP minus UQ is less than 0. Therefore, we can say that potential energy, the difference between potential energy is negative. Now we'll go for point A and B. What we have proved previously, VA value is less than VB. Potential energy at A equal to charge into VA. Similarly, potential energy at B equal to charge into VB. Which is more negative? We are more negative. UB is less than UA. Therefore, UA minus UB is greater than 0. Therefore, answer is positive.